Section 5.8 is on variation and applications, and there are 6 objectives. One would be to find an equation of direct variation given a pair of values of the variable, and then solve applied problems involving direct variation, and then finding an equation of inverse variation given a pair of values of the variables, and then again solving applied problems involving inverse variation. And then there are 2 more sections here to find equations of other kinds of variation given values of the variables, and then solving applied problems involving other kinds of variation. So if you've never seen variations before, this may seem a little mysterious, so let me just give you a quick overview, and then we're going to go into the details. So first of all, direct variation is this: y varies directly as x, where k is a non-negative number. And then inverse variation, this is just an overview here right now. We go into a lot of details in just a moment. So inverse variation is y equals k divided by x, again where k is the constant of variation. And then there's joint variation, in other words, where y depends on more than one variable, joint variation. Y equals k times x times z, k times x times z, again where k is the constant of variation. And then the others, they can be combined, these variations can be combined. In other words, I'm going to write others here. Again, we're going to go into more detail on that later on. So others would be, for example, where y is equal to k times xz squared divided by w. In other words, y varies jointly as x and the square of z, and inversely as w. So that would be that kind of variation. And we'll be looking at all of these variations. So here's the long explanation of direct variation. If a situation gives rise to a linear function, f of x equals kx, or y equals kx, where k is a positive constant, we say then we have direct variation, or y varies directly as x, or that y is directly proportional to x. And that number k is called the variation constant, or the constant of proportionality. So these terms are used interchangeably. Again, it's just definitions here right now. We haven't done anything yet. As you will see, variation problems are pretty straightforward. For example, find the variation constant and the equation of variation in which y varies directly as x. So in other words, we're looking for an expression y equals k times x. And find it when y equals 8, and y equals 8 when x equals 20. So y equals kx, that's direct variation. So 8 when y is equal to 8, when x is equal to 20, so k times 20. And now we find what k is by solving the equation for k. So we divide both sides by 20, so k is an 8 divided by 20, or k is equal to 2 divided by 5. So the variation constant is 2 divided by 5, and the equation of variation is 2 divided by 5, or 2/5 times k. So it's very straightforward. Similarly, when you look at the next exercise, find the variation constant in an equation of variation in which y varies directly as x and y equals 5.6 when x equals 8. So in other words, we're looking at y equals k times x. So y is equal to 5.6. equals k times 8, x equals 8, so k times 8. So in other words, k, we divide both sides by 8, so 5.6 divided by 8 is equal to k. Or k is equal to 0.7, so that's one result. And the equation of variation, that was the other question, what's the equation of variation? Well, it's y equals 0.7x. So in these type of problems, there are usually two questions, what is k and what's the equation of variation. So here we have Ohm's law, an example of physics, and states that the voltage in an electric circuit varies directly as the number of amperes, I, of the electric current in the circuit. So this tells us that V is equal to K times I. Then we are told if the voltage is 10 volts, so V equals 10, equals K times I, and I is equal to 3 amperes. So then K is equal to 10 divided by 3. And our equation of variation is V equals 10 thirds times I. And the question is, what is the voltage when the current is 15 amperes? So in other words, when I equals 15 amperes or amps. So now we multiply the right side by 15 because I equals 15. So V equals 10 thirds times 15, and 3 goes into 15 5 times, and 10 times 5 is 50. So it's 50 volts. That is the voltage. The next exercise is about bees and honey, and it says the amount of honey H produced varies directly as the number of bees who produce the honey. It takes 15,000 bees to produce 25 pounds of honey. How much honey is produced by 40,000 bees? All right, so here it says H, the amount of honey produced, varies directly to the number of bees. So we are told that 25 pounds of honey is equal to K times 15,000 bees. 15,000 bees. So K equals 25 divided by 15,000, which is equal to 5 divided by 3,000. So in other words, our equation of variation is H equals 5 divided by 3,000 times B. So now when we have 40,000 bees, that means 5 divided by 3,000 times 40,000. So it would be 200,000 divided by 3,000, or 200 divided by 3. So the amount of honey produced would be 66 2/3 pound. Let's take a closer look at inverse variation. I mentioned it briefly in the beginning, so let's look at it in more detail. So if a situation gives rise to a function f of x equals k divided by x, or y equals k divided by x, where k is a positive constant, we say that we have inverse variation, or that y varies inversely as x, or that y is inversely proportional to x. And again, the number k is called the variation constant, or the constant of proportionality. So let's look at an example right away. And so here we find the variation constant and the equation of variation in which y varies inversely as x. And y equals 0.012 when k equals 50. So here's our basic equation. Y varies inversely as x. And so now y equals 0.012 and x is equal to 50. So to find out what k is, we multiply both sides by 50. So we multiply 0.012 by 50. So k is equal then to 0.6. So the variation constant is 0.6. And the equation of variation is y equals 0.6 divided by x. The next example is about cleaning bleachers. The time t to do a job varies inversely as the number of people p who work on the job, assuming that they all work at the same rate. It takes 4.5 hours for 12 people to clean a section of bleachers after a NASCAR race. How long would it take 15 people to complete the same job? So we have inverse variation. So we have t, the time, equals k divided by p, the number of people. And so we have 4.5 hours for t equals k divided by the number of people here was between 12. So then k equals 4.5 times 12, which is 54. So then t is equal to 54 divided by p. So now we can answer the question, how long will it take 15 people to complete the same job? So now p is equal to 15. So we have 54 divided by 15. And that is 3 and 9/15. 9/15. And so t is equal to, 9/15 would be 3 3/5. So we can say that would be the same as 0.6, so t equals 3.6 hours. It would take 15 people 3.6 hours to do the same job. In the next exercise, we have current and resistance. And so the current I in an electrical conductor varies inversely as the resistance R of the conductor. So in other words, I equals K divided by R. Now we're told if the current is 1/2 ampere when the resistance is 240 ohms, what is the current when the resistance is 540 ohms? So we need to find the constant of variation. So we are told that 1/2 amperes for the current is equal to K divided by the resistance of 240. So we solve this equation for K by multiplying both sides by 240. And so 240 times 1/2 is equal to 120. So our equation of variation is equal to 120 divided by R. Now, what is the current when the resistance is 540 ohms? So the question is, when we place R now with 540, 120 divided by 540, we can reduce this to 2/9. Divide both sides by 60, and so it's 2/9. Of course, would be amperes or ampere. The next exercise asks us to find an equation of variation in which y varies inversely as the square of x, and y equals 1/4 when x equals 6. So this tells us that y is equal to k divided by x to the second power. It varies inversely as the square of x. Now we know that y equals 1/4 equals k divided by 6 squared, or k divided by 36. So when we take the equation k divided by 36 equals 1/4, we isolate k by multiplying both sides by 36, and 36 divided by 4 is equal to 9. So our equation of variation is then y equals 9 divided by x squared. Next, we have a statement of joint variation. Y varies jointly as x and z if there's some positive constant k such that y equals k times x times z. Here's an example of joint variation. Find an equation of variation in which y varies jointly as x and z, and y equals 65 when x equals 10 and z equals 13. So the equation looks like this. Y equals k times x times z. So y equals 65 equals k times x, and x is 10. So in other words, 65 is equal to k times 10 times 30 is 130, or k is 65 divided by 130, or k is equal to 1/2. So the equation of variation is 1/2 times x times z. Next, we define an equation of variation in which y varies jointly as x and the square of z, and inversely as w. So in other words, that looks like this. Y equals k times x times z squared divided by w, because we are told inversely as w. So now we are told y equals 80 equals k times x, which is 4, times 10 to the second power, divided by w, which is 25. So that means that k times 4 times 100 divided by 25, and 25 divided by 100 divided by 25 is 4. So then 80 equals k times 4 times 4 is 16. So we divide both sides by 16. So then k is equal to 5. So then our equation of variation, then is equal to y equals k, which is 5, times x times z to the second, or z squared, divided by w. So that is our equation of variation. That's a 5 here. In the combined gas law, we are told that the volume V of a given mass of a gas varies directly as the temperature T and inversely as the pressure P. So what does that mean? Well, that means that the volume varies directly, K times T, back to the first direct is the temperature T, and inversely proportional to the pressure P. Given that V is 231 cubic centimeters when T equals 42 degrees and P equals 20 kilogram per centimeter squared, what is the volume when T equals 30 and P equals 30 degrees and P equals 15 kilograms per centimeter squared? Well, let's first find out what the concept of variation is. So we use that V equals 231. 231 equals K times T is equal to 42 degrees divided by pressure of 20 kilogram per square centimeters. So then K, solving for K, is equal to 231 times 20 divided by 42, and that is equal to 110. So our equation of variation is V equals 110 T divided by P. For a given temperature of 30 degrees and a given pressure of 15 kilogram per square centimeters, this will then become 110 times T, our temperature of 30 degrees, divided by the pressure of 15 kilogram per centimeter squared, and that's equal to 220. 15 goes into 32 times, and 2 times 110 is 220 cubic centimeters, or centimeters cubed. So that will be the volume when T equals 30 degrees and P equals 15 kilogram per square centimeter. The last example is the volume of a tree. The volume of V of wood V in a tree varies jointly as a height h and the square of the girth g. Girth is distance around the tree. If the volume of a redwood tree is 216 cubic meters, when the height is 30 meters and the girth is 1.5 meter, what is the height of a tree whose volume is 960 cubic meters and the girth is 2 meters? So let's write down the equation of variation. So V, the volume, varies directly, so K times the height times G, the girth squared. And so now we are given that if the volume V is 216 cubic meters equals K times the height, which is 30 meters, times the girth, which is 1.5 meters squared. So then 216 is equal to 2.25 times 30 is 12.8 H, k rather. So now we divide both sides by 12.8. So k equals 216 divided by 12.8. And that's equal to 33.2. So 30 times 2.25 is actually 67.5. 67.5. So then k is 216 divided by 67.5, and that is equal to 3.2. So our equation of variation then equals v equals 3.2 times h times g squared. So now we want to solve for h because we asked for the height of a tree. So when we solve this equation for h, then h is equal to v divided by 3.2 times g to the second power. And since the given volume is 960 cubic meters, 960 divided by 3.2 times 2, g is 2 squared. So that is 960 divided by 12.8, and that's equal to 75. So the height of the tree is 75 meters. This is the conclusion of section 5.8, and it concludes chapter 5.